When making these rolled tubes, the problem is that the edges don't align perfectly. So there's straight edge here, and it's nice and curved all around. That problem usually stems from the fact that bending machines, all types, have some minimum bend distance. So let's say we're bending our sheet metal. Each of that line is the distance that we adjust the back gauge. Quickly make this aluminum piece for comparison, and with this it's actually a bit closer, and we can have a look how close that tooling gets on that last bend. So as you can see, it's quite close now. It barely fits in the tooling. There's a small groove here. If you put our stock here, you can see it barely has something to grip. So we can't get it closer. And that's where our minimum bend distance comes. That is how tooling looks on this machine from the side. You can see the line where the press brake was doing its thing. Maybe the drawing is not the best. But what we want to do, we would want to add 1 or 2 more bends here on that last piece. The simplest way is to just plan it and make it longer. So you have to cut it off at the end. Let's say we bent it the machine. In here it's 9 millimeters is the minimum distance. If you make it 5 millimeters longer, that means the bend line is 4 millimeters away from the edge then. And that's already pretty good. But we would have to cut it off. Another way to do it, if you don't want to cut it, let's say you already have the sheet metal ready, you can't cut it shorter anymore. Ideally, before doing that bend, we want to manually bend that end. Now, the easiest way to do it is just to place it over the edge of a table. Perfect table. We put our sheet metal over it, and if you clamp down a steel pipe or whatnot and use some C-clamps, then we can hit that part with a hammer. Yes, very highly scientific and precise maneuver. If you want the surface finish to be nice, we would have to hit it with a wood, plastic, aluminium, or some other medium between the hammer and the sheet metal. And also probably on the table if you want to have that scratch-free surface here. I have marked a line here where I want to bend it. The table is not exactly perfect for that because it has some radius which isn't 100% uniform, but just to demonstrate, it will do just fine. We want to use some bigger stock on top of it. The bigger stock is needed so it doesn't bend up when you hit it. As you can see, it is nice and sturdy now, it's not going to go anywhere. What you can do is also use the side of that wood if the force is too hard, but that will also make it less even, or you have to be more precise when you hit. I like to start with the corner so I can see how it moves, but I need to use more force in the middle. So let's try it. I don't know if you can see, it actually bent down quite a lot because the radius of the table, the edge of the table, we have a bit more curved edge that we want, but that's not really important for this video. I just want to show you how to hit it down. And if you want, you can always hit it back. Let me just show you how it looks from the front. As you can see, it's not the most even right now. If you cover it like that entirely, but you have to take these away, then you can get more uniform, but it takes so much more force to hit it. But we can also eyeball it and correct it, see where the high points are. It's getting quite good. The middle part is actually overbent now. As you can see, it looks quite uniform now. As you can see, we made a quite nice bend. It's a bit further from the distance that we wanted because the radius of the table, but that doesn't really bother me right now. As you can see, because we didn't put any tape or wood or plastic, it does scrape into a bit. So if you want to make it clean, you have to use wood. It's actually really clean. You don't see any hammer marks. Up here you see the line where we wanted to place the edge. As you can see, the edge is very round. The side of the table has a lot more sharper corner. We can just do that for fun. Let's clamp it down. We do have a bit of a more over the edge right now. And now we have actually a very nice sharp end. See, because the table is sharp, the edge, it also made a sharp end. Well, not 100% sharp because it's still a bit worn edge. How are you going to weld it? The problem with placing hot metal on it is that it's already expanded. So when it starts to cool down, it starts to contract. So if you place hot metal above here, it is just going to bend these edges up a bit. So if you make it perfectly round, let's say we make it perfectly round, that connection is perfectly round here, it will end up being kind of not that crazy, but a little bit like that. So we do want to make it, well, you can't really see here, but we want to make it a bit sharp. You can also see that middle bend on this welded aluminum pipe. And also one thing to consider is the lengthwise. But if you start welding it, what it will do, it will bend this way. Maybe it's a bit hard to see, but you can see the middle sagging and tops are a bit higher on the left and right side. That the edges are pulled up while the middle part is sagging. Not too bad, but you can definitely spot it. Now when we check the rollers, as you can see, there is not much here. And you can see that press brake lines, and you can see where that roller took over. And the lines are so far because the rollers also have minimum bend distance